Welcome to this video on the topic of linear functions. In this video, we're going to have a look at how we can deduce the equation of a line. Now for this video, it's been split up into three sections. In the first two sections, we're going to have a look at how we can deduce the equation of a line. In the first part being with a point and the gradient, and in the second part, how we can do it using just 2 points. Now in the third section of the video, this is where we're actually going to be looking at a question that you could get assessed on in general mathematics. So the first two sections are simply about building up fluency, and in the third section it's about looking at how we can do questions that are accessible. Now for section 1, we're going to have a look at how we can deduce the equation of a line using a single point and a gradient. If we turn our attention down to the graph shown over here, which is not drawn to scale by the way, we have a single point and we have the gradient, m equals 0.75. Now the way in which we can go about deducing the equation of this purple line over here is we're going to use the gradient formula, that being defined as m equals y2 minus y1 over x2 minus x1. Now this is the formula we simply use to be able to deduce the equation of this purple line. However, I'm going to make two modifications. First one being is I'm going to scrub out the y2 subscripting, so it's now going to be y minus y1. Then I'm going to scrub out the x2 subscripting, so it becomes x minus x1. Now the way in which this formula is going to be useful is because we have a single point over here, that being our x1, y1, and we have our gradient over here. All we need to do is simply substitute these three values we have into this formula and then rearrange to make y the subject, therefore giving us the equation that explains this graphical line over here. Now putting this to practice, the way in which I'm going to set it out is I'm going to write out my coordinate, and then I'm going to write out my gradient. So I'm just listing my information so it's convenient to read. Next step is I am going to label my x1 and my y1, and I might as well do my m as well. Moving down, I recite the formula m equals y minus y1 over x minus x1. Now I need to simply substitute in the values. M is 0.75, y is still y, it's a variable, and y1 is my 15. Take x, or divided by x, take 0. Next step is I am going to rearrange to solve for y. So to do that, I'm going to multiply both sides by x minus 0 to get rid of this fraction. And then this is going to yield 0.75, x take 0. Alright, moving down, we expand the brackets. 0.75 times negative 0 is nothing. Add 15 to both sides of the equation, and therefore what we find is that y is equal to 0.75x plus 15. Therefore the equation of our line is described as y equals 0.75x plus 15. So in summary, the way in which we can deduce the equation of a line when we're given a point and a gradient is we simply use this formula over here. Substitute in the values, rearrange for y. If you want to move it into general form, then you just move the x onto the left side and multiply everything by minus 1. That would give you general form. Alright, moving down, we're looking at a second method in which we can deduce the equation of a line. In this situation over here, we're given 2 points, the x-intercept and just an arbitrary point over here. Now using these two pieces of information, we're going to deduce the equation of a line. Now the way in which we do that is we still use the gradient formula. So y minus y1, then x minus x1. Now the way in which we're going to plug m into this equation is we're going to do some clever manipulation of the value of m. Rather than being given the gradient, we're given 2 points, and we know that the gradient can be calculated through the 2 points by writing y2 minus y1 over x2 minus x1. And therefore, we have a formula we can use over here that requires 4 unknowns, or that requires 2 ordered pairs or 2 points on our line. Now, to be able to solve or to be able to deduce the equation of this line, we're going to write our points out. So 10, 5, and then we have it's 5 and 0 because we're cutting the x-axis there. Now labeling the points, we have x1, y1. Doesn't really matter which order you do it in. We'll both give the same answer. So long as x1s and y1s together, x2s and y2s are together. And then we're going to write out the formula. Subbing in the values, y2 in this case is 0, take 5. Then we have x2, 5, take 10. Going across, we have, this will give us a value of minus 5. 5 take 10 is minus 5. So overall it's going to be 1. 5 divided by 5 is 1. Then y minus 5. Now solving for this, we're going to multiply both sides by x take 10. This is going to give us x take 10 is equal to y minus 5. Expanding the brackets. And then we're going to rearrange for y as the subject. So we're going to add 5 to both sides. Therefore, we're going to find that y is equal to x take 5, which seems to match the pattern that we see regarding the line over here. Positive gradient, negative y-intercept seems to match up. Now if we wanted to move it into general form, then we simply move the x across, so it's going to become minus x plus y equals minus 5. And then we don't like having negatives on the x, so it becomes x take y plus 5. So that's general form. Alright, so these are the two techniques that we need to have mastered to be able to enter the next section. So part 1, we had a look at calculating or deducing the equation of a line when we have a point and a gradient. We simply use this formula over here. And then method 2, we deduce the equation of a line using this formula over here. So we have 2 points. Simply calculate the gradient, then sub in one set of points into here. Now that we've got these two out of the way, we can start looking at contextual problems. These are the sort of problems that you could be assessed on in Stage 1 General Mathematics. Example: the graph below shows the cost of calling out a plumber with an hourly rate of $50. Find the equation that represents the plumber's fees. So what we have over here is a graph that's not drawn to scale, however it's been annotated, so therefore we're able to pull information from it. Of which the annotation we have is as a y-intercept at $120 by the looks of it. Furthermore, reading the question more closely, we are able to deduce that there is an hourly rate of $50, which implies that the gradient of this graph is 50. Now the information that we can extrapolate from this graph is, well, we have the point, we have the y-intercept, and that's at a value of 0, 1. Thus what we have over here is we have a point and we have a gradient. As such, we compute the equation of the graph as m equals y take y1 over x take x1. Writing out our values, we're going to get 0 and 120. Then we're also dealing with m equals 50. We have our x1 here, y1 here, and then we have our m over here. We're now going to sub in the values. So m, which is now 50, is equal to y take 120 over x take 0. Breaking this out, we're going to times both sides by x minus 1 or x minus 0. Following this down, we're going to get 50 multiplied by x minus 0. Then we're going to get y. Breaking out the brackets, we're going to get 50x, then 5 minus 120. And then solving for this, we're going to get y is equal to 50x plus 120. Observing the equation of the line that we believe we have deduced, it's 50x plus 120. If we compare it to our graph over here, the 120 is a constant. We expect it to be the y-intercept, and the positive 50 we might expect to see a more steep bar gradient. However, because it's not drawn to scale, all we need to really look for is it going up or is it going down the line? In our case, the line is going up, and this is in agreement with the value of the gradient, so it's positive gradient. So what we can say is that the equation represents a plumber's face, so here's our equation over here. So here's our answer. Again, if we wanted to represent this in general form, then we can write it as 50x minus y minus 100. Going down, we have determined the fee for 5 hours worth of work. Now, to be able to do this, we're going to simply start off by writing the equation out again. Now, we need to observe the axes on our chart above. So it says determine the fee for 5 hours worth of work. So our y-axis represents the cost, and our x-axis represents the hours. As a result, what we're going to find is that if we go to, say, 5 over here, this location here on our x-axis or y-axis is going to tell us how much money we've made. Consequently, the way in which we're going to enter the question is we're going to say let x equal 5. Computing this, 50 times 5 is 250 plus 120. And therefore the value of y is going to be 370. So what we can say is, therefore, the fee for 5 hours of work is $370. Now, this sort of problem may also be solved on your technology or your calculators. The way in which we do this is we're going to bring our calculators up and we're going to go into graph mode, so 5. From there, we input the model that represents the fee for your work. So it's 50x plus 120. Then we graph. Now, if this graph has already been set up, if your graph is all over the place, then you can click on auto like this, and it will give you something reasonable. Or another way to think about it, you can use F3, and you can set the window yourself. So the values of x we're looking at, so x min and max, we're looking at between 0, because time starts at 0, and then we're looking at least 5 hours. I'll just put in 10, a good measure. Secondly, the value of minimum, so we're looking at the cost. So in my case, or in our case, the graph itself should start at 0 for $0. And then the maximum, we want to go up to above 120. So let's say go for 600. Graphing this, we get our graph over here. Now, to be able to solve for the value of 5 hours worth of work, we go to G-solve, F5, go across one, and we click on ycal, of which we put in 5 hours for x, and then it reveals to us that the value of y when x is 5 is 370. Now, the way in which we'd show this in a test condition is we'd say using calc, and then we'd write x equals 370, therefore blah blah blah. So basically what we said over here. Now, the technology solution to this problem is completely adequate, provided that the question doesn't say show or demonstrate algebraically. If it just says calculate or compute, then use the calculator. Moving on, we have part C, determine the hours required to earn $500. Basically a similar question to what we did before. We're starting off with our mathematical model. Y equals 50x plus 120. Going down, we're going to say let, and in the previous question we let x equal the value because we're looking for 5 hours worth of work. In this instance, we're determining how many hours required to earn 500. So it's no longer x being 500, it's y is 500. Another giveaway is the fact that it's dollars. Simple transformation because I like smaller numbers. And then we're going to rearrange for x. So to do that, we're going to take 12 from both sides. This is going to yield a value of... Alright, now I can't do this in my head. So what I'm going to do is I'm going to get my trusty calculator up. I am going to key in my value. So I'm going to go backwards, and then we're going to go 38 divided by 5 is 7.6. So therefore, the cost required, the hours required to earn $500 is 7.6 hours. Now once again, using our technology to solve this problem, we go back, we go to graphing, we graph our graph, and then we go to gsolve, across, over to, I believe it is xcal. Now putting in y value, so we're looking for a y value of 500, we observe that our x is at 7.6. So once again, to show that we're solving this problem, we write using calc. X is equal to 7.6. Therefore, blah blah blah, basically what we wrote over here again. Alright, so in summary, what we first had a look at in this video was how we can deduce the equation of a line. We did this using two methods. Firstly, the pointing gradient, using this formula. Then we did the two-point method, using 2 points, so two arbitrary points on a graph. It could be intercepts, or it could be an arbitrary point like shown here, of which we plug them into this formula, which is effectively the same as this guy up here. Going down, we then had a look at how we can apply this knowledge, of which we looked at this contextual problem.